Whenever the three equations are given, you need to write three matrices, that is matrix A, matrix X and matrix B. The question you can expect from the chapter binomial theorem is finding the middle terms, finding the general terms, finding the term independent or constant term, or finding the coefficients of any variables. Based on the conditional statement, if the first statement is true, second statement is false, then the compound statement will be false, and in all other cases it is true. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in this session, let's continue the revision of your model question paper. So in our previous session, we have solved the question paper until part C section. Let's look at the next section, part D. So here in the part D section, you will be given 10 questions and you are supposed to answer only 5 questions. So let's see the questions you have. One questions on matrices, that is solving the determinants and finding the linear inequalities, find the value of x, y, z here. Next you have one question on the binomial theorem. Here the question is given to find the coefficient. Next you have to resolve a partial fraction into two simple fractions. Next we have a question from mathematical logic. Next from the ratios and proportions, a question on learning curve, linear programming problem from transformation formulas from the chapter trigonometry, differential equations especially from second order derivatives, and the application of integrals to find the areas under the given curves. So let's solve these questions. Solve the linear equation using the matrix method. So the equations will be given. Whenever the three equations are given, you need to write three matrices, that is matrix A, matrix X and matrix B. So matrix A contains the coefficients of x, y and z, that is 3, 1, 2, 2, minus 3, minus 1, 1, 2 and 1. Matrix X contains the variables x, y and z. Matrix B contains the constants, that is 3, minus 3 and 4. The first thing is you need to find the value of the determinant A. So when you find the value of the determinant A, it should not equal to 0. So on solving the value of this determinant, I'll get the value as 8, which is not equal to 0. So what does indicates? It indicates that A inverse exists. Why A inverse is necessity here? Because we need to solve the equation x is equal to A inverse B to find the individual values of x, y and z. Now, after that A inverse exists, we need to find out the value of A inverse. We know that A inverse is given by 1 over determinant A into adjoint A. Anyhow, we have found the value of determinant A, that is 8. Now, next we need to find out adjoint A. So, adjoint A is that it's a transpose of your cofactor matrix, that is you're supposed to find the minor of all the elements inside the matrix A and then transpose it, you will get adjoint A. So now for this matrices, the adjoint A is given by minus 1, 3, 5, minus 3, 1, 7, 7, minus 5 and minus 11. So this is your adjoint A. Now using adjoint A, we can just substitute A inverse as 1 over determinant A by adjoint A, and using this equation x is equal to A inverse B, we have x as x, y and z, A inverse as 1 over 8 into adjoint A. Adjoint A is given by minus 1, 3, 5. Next we have minus 3, 1, 7. Next we have the last row 7, minus 5, minus 11. Next we need to multiply this with matrix B, that is 3, minus 3 and 4. On multiplying and solving this, we will get the column matrix. So the column matrix value is 8, 16 and minus 8. So which will give you x, y, z. And dividing all these things, we will get a final column matrix as 1, 2, minus 1. So therefore, the value of x is 1, y is 2 and z is minus 1. So this is how using matrix method, we will find the individual values of x, y set. So there will be one question on matrix method. So that is using simultaneous linear equations and matrix method, we are finding the values of x, y and z. Next question we have, find the coefficient of x power 5 in the expansion of x plus 1 by x square whole to the 17. So here any binomial term is given. The question you can expect from the chapter binomial theorem is finding the middle terms, finding the general terms, finding the term independent or constant term, or finding the coefficients of any variables. So here for all these questions we need to write the formula of the general term. So that is T r plus 1 NCR a to the power n minus r b to the power r. So here we don't know which term we are finding. So let's write T r plus 1 as it is. We know n there, which is 17 CR. The value of a is x to the power 17 minus r here, and b is 1 by x square whole to the power r. So on solving this, we'll get TR plus 1 is equal to 17 CR, x to the power 17 minus r, here we have 2 times r minus 2r we'll get. So now we need to compare the coefficients of x power 5 with this. So this implies 17 minus 3r is equal to 5. We can take, or we can take here 3r is equal to 12. So therefore r is equal to 4 now. Substitute r is equal to 4 here, we'll get T4 plus 1 is equal to 17 C4. So we have equated 17 minus 3r as 5. So we will get here x to the power 5. So this is what we will get. So what is the coefficients of x power 5 here? It is 17 C4. So therefore the coefficient of x power 5 is 17 C4. Next we have a question on partial fraction. So a rational function will be given. We need to express this into simple fractions. Now let us consider the rational function x square plus 1 divided by x plus 1 x minus 2 whole square. Remember, the degree of the numerator should be always less than the degree of the denominator. Then we can resolve them into simple partial fraction. Otherwise, we need to write it, convert it into a form of sum of a polynomial and the rational function, and then find the partial fractions. So here clearly we can see degree of the numerator is less than the denominator, and using the rules of partial fraction, so here we have a repeated linear factors. Thus I can write this as a divided by x plus 1 plus b divided by x minus 2 plus c divided by x minus 2 whole square. So on solving this, we will get x square plus 1 is equal to a into x minus 2 whole square plus b into x plus 1 x minus 2 plus c into x plus 1. Now to find the value of a, b and c here, so use the linear factors given. So for the first case, put x is equal to minus 1. So this implies, so here we will get this as 2. So wherever you have x plus 1, you can take it as 0. So here b and c becomes 0. So clearly we can see here, so we'll get here. So minus 1 minus 3 whole square, which becomes 9a. So therefore a is equal to 2 by 9 we'll get. Next we can take x minus 2 as 0. So that implies x is equal to 2. On solving this, if you take x is equal to 2 here, we'll get 5 here. So wherever you have x minus 2, you can consider them as 0. So we will get 3c, or we can get c is equal to 5 by 3. Next, either you can take x is equal to 0 because there is no another linear factor to equate it to 0. So we can take x is equal to 0, or we can follow the method of equating the constant on both sides, equating the coefficients of x on both sides, or equating the coefficients of x square on both sides. So let me equate the coefficients of x square on both sides. So let's see what are the coefficients of x square on both sides. On the left hand side, the coefficient of x square is 1. On the right hand side, the coefficient of x square term is a as well as b. So therefore, this is a plus b here. A we got it as 2 by 9. So therefore, on solving, we will get b as 7 by 9. Next, substituting all the constant a, b, c, x square plus 1 divided by x plus 1, x minus 2 whole square can be written as 2 by 9, that is x plus 1 plus 7 by 9, x minus 2 plus 5 by 3, x minus 2 whole square. So thus we have resolved them into simple fractions. So next you will be getting one questions from mathematical logic, that is to find the logical equivalence or to find whether the compound proposition is a tautology or contradiction or neither tautology nor contradiction. Let's verify it. Verify whether the compound proposition P conditional not P disjunction Q is a tautology or a contradiction or neither. So based on the statements, I have written the tabular here. So we need two statements P and Q. So let me take P as true, true, false, false, Q as true, false, true, false. Now from the compound proposition, we need negation of P. So negation P becomes false, false, true, true. Next we need negation P or Q, that is disjunction. For disjunction, when both the statements are false, it is false. So let's see. So where we can find both the statements are false. So there is no two statements which are false. So therefore we can write all the statements as true here. Next we need the conditional statement. So based on the conditional statement, if the first statement is true, second statement is false, then the compound statement will be false, and in all other cases it is true. So therefore let's find true, false. From these two tables, we are not getting the first statement as true and the second statement as false. So therefore all the statements are true. So clearly from the last column we can say, so for all the truth values, the given compound proposition is true. So that means it is a tautology. Next question. 4 men or 12 boys can do a piece of work in 5 days by working 8 hours per day. In how many days 2 men and 4 boys can do the same piece of work by working 12 hours a day? So 4 men or 12 boys. So that means we have a ratio here. 4 men is nothing but 12 boys. So this indicates 1 man is equal to 3 boys. Now here, next we need to find out how many days 2 men and 4 boys can do the same piece of work. So again, 2 men plus 4 boys means 6 plus 4, which is equal to 10 boys. So from the given question, 12 boys can do a piece of work in 5 days. So 12 boys, so here I'll write boys and here I'll write days. So 12 boys can do a work for 5 days. So number of hours given is 8. Next I need to find out for 10 boys, because 2 men plus 4 boys means it is 6 boys plus 4 plus 10. So 10 boys, in how many days they can complete the work, same piece of work by working 12 hours a day. So clearly we can see 12 is to 10 is equal to x is to 5, an inverse proportion. Also we have 12 is to 8, which is also an inverse proportion. We have a 3 ratios, and number of boys decreases means number of days increases. So therefore it's an inverse proportion. Here also number of boys decreases means number of hour increases. Again it's an inverse proportion. So on solving this, we'll get x is equal to 12 into 5 into 8 divided by 10 into 12. So we can cancel here. 5 ones are 5 twos are. So 4. So x is equal to 4 days. So next we have a problem on learning curves. An engineering company has 80% learning effect and spends 1000 hours to produce one lot of the product. Estimate the labor cost of producing 8 lots of the product if the labor cost is rupees 40 per hour. So the labor cost per hour is given. So first let's find out the total number of labor hours using the tabular method, and then we will find the labor cost. So for that we have a tabular column, that is units produced. It can be converted into lots also. So total output in lots, it is also units. Cumulative average time per unit. So based on the learning effect and total hours. So clearly to produce one lot, the total output will be 1. So the first time it has taken 1000 hours. So here also it is 1000. Now next I am producing one more lot. So the total lots will be 2. So now here an 80% of learning effect is given. So therefore it will be 80% of your previous average time per unit. So 80% means it is 800. So total will be 800 into 2. So that is 1600. So next let's double it. So the total will be 4. So 80% of 800 means it is 640. Now 640 into 4 will be equal to 2560. Next again here let's double it. So 4. So the total lots will be 8 here. So 80% of 640 will be 512. Next 512 into 8 will be equal to 4096. So therefore we will stop here. So clearly we can see here total labor hours, that is equal to 4096 hours. Now total labor cost we need. So that means for 4096 hours into 40, so the value will be equal to 1,63,840 in terms of rupees. So this is the total labor cost. Next, we have one questions on linear programming problem. Solve the LPP graphically. Maximize z is equal to 6x plus 8y subject to constraint 4x plus 2y less than or equal to 20, 2x plus 5y less than or equal to 24, and x comma y greater than or equal to 0. So here x comma y greater than or equal to 0 means my solution lies in the first quadrant. So this is x, y, origin is 0, 0. Now let's solve this straight line. So let us take the first equation, 4x plus 2y is equal to 20. Let's find the coordinates now. If you take x as 0, you will get y as 10. If you take y as 0, you will get x as 5. So next, let's solve one more equation. We have 2x plus 5y is equal to 24. So we have x and y. So if you take x as 0, y will be 4.8. And if you take y as 0, x will be 12. So we can take the units as 2, 4, 6, 8, 10, 12, 14. Here also 2, 4, 6, 8, 10, 12 and 14. So the first one we can take it as 0, 10, and the next we have 5, 0. So this is a straight line. And the equation of that line is 4x plus 2y is equal to 20. Next we have 2x plus 5y is equal to 24, that is 0, 4.8 somewhere here. Next we have 12, 0. So on solving this, and we have here less than or equal to 20, less than or equal to 24. So from these linear inequalities and from the graph, we can clearly see the region, which is a quadrilateral, is the solution region for the given set of linear inequality. Once you got the solution region, you need to identify the corner points. So these are the corner points we'll get here. So what are the common corner points here? The first one is origin. The second one we can take it as A. So which is 5, 0. The third one, by observing the graph, we can write. So we will get usually B value as 3.3, 3.5 approximately we get, and the value here you will get it as 0, 4.8. So now substituting all these in the corner point table. So we have here corner points. So that is origin 0, 0, A 5, 0, B 3.3, 3.5 and C 0, 4.8. And we have an objective function z is equal to 6x plus 8y. So substitute the value of x, y in each of the corner points and find the value and then find out the maximum value. So for 0, 0 we can clearly see it is 0. For 5, 0, 6 5 is a 30. Next we have 3.3 into 3.5, 6 into 3.3 plus 8 into 3.5. On solving we will get this as 47.8. Next 6 into 0, 0, 8 into 4.8, we will get the value as 38.4. Clearly from the table, Z max is 47.8 at the corner point 3.3, 3.5. So thus the solution of the LPP lies on the corner points and the maximum value is 47.8 at 3.3, 3.5. So next we have a problem from trigonometry. So that is a transformation formula you need to use here. So let's consider the LHS part. So we have sine 6a plus sine 2a plus 2 sine 4a. Next we have sine 7a plus sine 3a plus 2 sine 5a. So let's use the transformation formula for the first two terms in the numerator and denominator. We know that sine c plus sine d can be written as 2 sine c plus d by 2 cos c minus d by 2. So c plus d means 6a plus 2a is 8a. So sine 8a by 2 means it becomes 4a. And cos 6a minus 2a is 4a. 4a by 2 is 2a plus 2 sine 4a. And here also same formula we are going to use, 2 sine c plus d by 2, that is 7a plus 3a is 10a, 10a by 2 is 5a, dot cos 7a minus 3a is 4a, 4a by 2 is 2a plus 2 sine 4a. Now we have 2 sine 4a as a common factor in the numerator. So it is cos 2a plus 1. And here also we have 2 sine 5a as a common factor. So cos 2a plus 1. So it get cancels here. 2 and 2 get cancels here. So we are left with sine 4a divided by sine 5a. That is RHS. Hence we have proved. Next we have the question from second order derivatives from the differential calculus. So here the question is given as y is equal to log of x plus root of x square plus 1. Show that x square plus 1 y2 plus x y1 is equal to 0. So let's find out dy by dx. So which is also nothing but y1. So here log of any function is 1 over x plus root of x square plus 1. So it is reciprocal of that function. Again let's derive this 1 plus root of x square plus 1. So when you derive it, derivative of x is 1. So root x means it is again 1 by 2 root x form. So therefore it is 1 by 2 root x square plus 1. Again when you derive x square plus 1 here, x square becomes 2x. Derivative of 1 is 0. So clearly 2 and 2 get cancels here. So now we are left with the denominator value. Here after multiplying the fraction, we will get root x square plus 1 plus x divided by root x square plus 1. So these two terms are same, we can get cancels. So we will get here y1 is equal to 1 divided by root of x square plus 1, or cross multiplying we'll get root x square plus 1 into y1 is equal to 1. Now squaring on both sides, we will get x square plus 1 y1 square is equal to 1. So next we will derive this again. So differentiating again, here we have two functions, we can use the product rule. So the first function into derivative of the second. Suppose if you have x square, we will write it as 2x, but here we have y1 square, we will write it as 2y1, and derivative of y1 is y2. Plus next we have y1 square, derivative of x square plus 1 is 2x, and on the right hand side it is 0. So clearly we have 2y1 as a common factor and we can remove it. So after removing it, we will get x square plus 1 y2 plus x y1 is equal to 0. So this is what we need to prove the relation. Hence we have proved here. Next we have a question from the definite integrals, that is to find the area under the curves. Find the area enclosed between the parabola x square is equal to 4y and the line x is equal to 4y minus 2. So we have two equations here, x square is equal to 4y and x is equal to 4y minus 2. So if you put 4y as x square here, then you will get the equation as x square minus x minus 2 is equal to 0. On solving this, we will get the two values for x because it's a quadratic equation. We'll get x is equal to 2 and x is equal to minus 1. So once you got the limits, the upper and lower limit, you can find the area. So area is always a to b f of x minus g of x dx with the variable x. So therefore here the total area becomes from the lower limit minus 1 to 2. So f of x is x square is equal to 4y. So in terms of y, we can write it as x square by 4. So therefore here it becomes x square by 4 minus, here it will become x plus 2 divided by 4 with respect to dx. So now here on solving this, we will get x square by 4 has, we can take 1 by 4 as a common factor from the integral only. So here we will get it as x cube divided by 3, and here we will get it as minus x square divided by 2, and here we will get it as minus 2x. So substituting the limits and solving this, we will get the answer as 9 by 8 square units. So this is how we are going to find the area of the parabola and the line using the definite integrals. So next we are at the last session of your model question paper, that is part E section. So we have question number 49, that is for 6 marks. You will be given 2 6 marks question. You are supposed to answer any one question. Similarly, question number 60 is for 4 mark question. So 2 4 mark questions will be given, that is you have to answer only one. Your 6 mark question is one from the circles, that is to prove the concept of concyclic, and the second one will be from the chapter limits and continuity. 2 important theorems are there in that chapter. So this is one of the theorem and the other one is the standard form of limit x tends to a, x to the power n minus a to the power n divided by x minus a which is n into a to the power n minus 1. So here in this model question paper, they have given this theorem. They might give this also. So you need to learn both the theorems so that you can attend any one of them in your examination. And for 4-mark question, we have a question from the chapter heights and distances. That is to find the height of the tower, distance between the boats, or the height of the building, length of the river, breadth of the river, etc. So, and next we have one question from binomial theorem under application of binomial theorem. So, let's solve these questions now. Now, the question is given, show that the points 0, 0, 2, -4, 3, -1, 3, -3 are concyclic. Concyclic means the point lie on the circle. So, whenever any point lies on the curves, it becomes the solution of its equation. So, the standard equation of the circle is given by x square plus y square plus 2gx plus 2fy plus c is equal to 0. Now, since the circle is passing through these points, let us consider these 3 points are the solutions for the circles. Then, from these points, we will get the equation as, so put at 0, 0, the equation of the circle becomes, so 0, 0, 0, 0, which will give you the constant c as 0. Next, at 2, -4, so the equation become 2 square, 4, 4 square, 16, 2 2s are 4g. Next we have 2 4s are -8f plus c, c from this equation we have got it as 0. So here we will get 20 plus 4g minus 8f is equal to 0. Next at point 3, 1 or 3, -1, we'll get this as 9 plus 1 plus 6g minus 2f plus c is equal to 0. Again we will get 10 plus 6g minus 2f is equal to 0. We can take this as equation 1, equation 2 and equation 3. Now solving equation 2 and equation 3, we'll get the value of g and f as -1 and 2. Now substituting these values in the standard equation, we'll get the equation of the circle as x square plus y square minus 2x plus 4y is equal to 0. Now let's take this as equation 4, which represents the standard equation of the circle. Now if 3, -3 lies on this circle, that is if it is the solution of this equation, then substituting the value of x and y, answer should be equal to 0. Now let's see here, x square is 3 square, y square is 3 square. So 3 square means it is 9 plus 9. Next we have x as 3, 2 3s are 6 we will get. So -6 we will get. Next we have 4 3s are, which is -12. So -12 we will get. Clearly 18 minus 18 is 0. So it is satisfying the given equation. So therefore from the first 3 points you can derive the standard equation of the circle, and the last point you can use it for the substitution, show that it is equal to 0. So then it says the given points are concyclic. If the solution is not equal to 0, we can directly write it is not concyclic. If the solution is 0, then all the points are concyclic. Next question. We have a theorem here, that is if the angle theta is measured in radians, prove that limit theta tends to 0, sin theta by theta is equal to 1. To prove this theorem, we need a construction part. Let us consider a unit circle. Let OA be the radius. So unit circle means the radius is 1 unit. Let us consider an angle AOC whose value is x radians. After that, draw two perpendicular lines, that is CD and BA, to the radius OA. Extend OC to meet B, join AC. So whatever the construction you have done here, so write the explanation. After that, from the figure we can clearly see that area of triangle AOC is strictly less than area of sector AOC, which is less than area of triangle AOB. So from the diagram. So using half into base into height formula, we can write here half into base is OA, height is CD. And here it is always theta by 360 we can write. So theta here is x, 360 is 2 pi because we have considered it in terms of radians into pi r square. R is nothing but OA square here. So, and this is also half into base into height. Since value of OA is equal to 1 and half is constant in all the inequalities here, pi and pi get cancelled. We are obtained with CD less than x less than AB. Now to find the value of CD and AB, we can consider two triangles, that is angle COD and AOB. So from the angle or the triangle COD, we'll get sin x as CD by OC. Now OC is the radius here. So therefore this implies we can write CD is equal to sin x. And similarly from the triangle AOB, we can get tan x. Tan x will be AB by OA. Again OA is the radius. So therefore we can write AB is equal to tan x. Now substituting the values here, we will get this as sin x less than tan x. Dividing throughout by sin x, we will get here 1 less than x by sin x less than 1 by cos x. Now taking reciprocals throughout, we will get cos x less than sin x by x less than 1. Apply the limit as x tends to 0. We will get limit as x tends to 0 cos x less than limit x tends to 0 sin x by x less than limit x tends to 0 to the 1. So when you apply limit as x tends to 0, cos 0 is 1. Do not apply the limit for the sin x by x. Now limit we can't apply for the constant function, so we'll keep it as 1. So you can see this function whose value is less than 1 as greater than 1. So that implies limit as x tends to 0 sin x by x is equal to 1. So since the variable is theta here, you can also take this in terms of theta. So this also implies limit theta tends to 0 sin theta by theta is equal to 1. So you can just take x is equal to theta there. So this is for positive. Suppose if we measure the angle in anti-clockwise direction, then let's take x is equal to minus theta. Then what happens, we will get here limit theta tends to 0. So sin of minus theta by minus theta. So which is limit theta tends to 0. So here minus theta means minus of sin theta divided by minus theta. It get cancels here. So again it is a standard form whose value is 1. So for both positive and negative values of theta, we are getting limit sin theta by theta is equal to 1, and hence we can conclude that limit theta tends to 0 sin theta by theta is equal to 1. Hence proved. So next we are moving for the last question, 4-mark question. So this is a question from heights and distances. And angles of elevation of the top of the tower from the base and the top of a building are 60 and 45 respectively. The building is 20 meter high. Find the height of the tower. So we have a tower here, we have a building here. So from the top of the tower, so the top of the building and the base of the building was observed and it was 60 degree and 45 degree. So therefore, so if we take this an angle of depression, so this is 45 degree and this is 60 degree. So I'll draw a parallel lines. So we can write this as 45 degree and this as 60 degree. So this is 20 meter. So approximately this will be 20 meter. We need to find out the height of the tower. Let me consider it as h. So this will be h minus 20. Let us consider this as A, B, C, D, E. So from the figure we can see here tan 45 is AE by EC. So tan 45 value is 1. So AE by EC, so AE is H minus 20. EC can be written as BD also. So let's write it as BD. So from this, we'll get here H minus 20 BD, or we can take BD is equal to H minus 20. Let's take it as equation 1. Also, if you see tan 60 degree, opposite by adjacent means. So tan 60 degree is AB by BD. So root 3, AB is height. So we have here H minus 20. Now, so H root 3 minus 20 root 3 is equal to H. Or we can say here H common we can take. So root 3 minus 1 is equal to 20 root 3. Or H is equal to 20 root 3 divided by root 3 minus 1. So in terms of meter. So you can rationalize and write the answer. So this is the height of the tower. So next we have the expansion of binomial theorem. So we have here 1.01 whole power 5. So this can be written as 1 plus 0.01 whole power 5. Using the binomial theorem, we can expand it. So the first one will be 5C0, 1 power 5, 5C1, 1 power 4, 0.01 plus 5C2, 1 cube, 0.01 whole square plus 5C3, 1 square, 0.01 whole cube plus 5C4, 1.01 whole power 5 plus 5C5, 0.01 whole power 5. Now let's find the expansion here. 5C0 is nothing but 1. 1 power 5 is 1. So it is 1. 5C1 is 5. 0.01 will get. 5C2 is 10. 0.01 whole square, which is 0.0001. Next we have 5C3. So which is 10 again. So 0.01 whole square is, so 0.000001 plus etc. we can write, because they have asked us to find or approximate up to 4 decimal places. So here 1 plus 0.05 we will get, plus 10 is 0.001 plus 0.00001. Adding all this, we will get 1.0510. 1 we will get, so we can approximate it as 1.0510. So thus we have solved the model question paper completely. I hope you understood the pattern of the question paper and how you can choose the number of questions in each sections and attend your answer. So wish you all the best for your examination. We'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.